welcome to today's lesson on parallel lines. So first of all, I'm just going to show us a little GeoGebra file on parallel lines, looking at this one here. So the first thing we're going to look at are these things called corresponding angles. I'm just going to make this big for you so you can see it. So here we've got corresponding angles. Now we notice that when we've got this, I can move this around here and notice that that top angle and that bottom angle there are staying, no matter how far I move them, exactly the same. And I could turn this like this, they are always going to be the same there. And these are called corresponding angles. Now, you can also flip this round and you can see that these two are the same. You can also flip them down here and see that these two are the same. You can also flip it here so you can see that these two are the same. Now, when we're looking at this, let's just have a little look at this. I just want to show you a little picture. So if I have some parallel lines like so, and I have a line which is crossing these parallel lines. Sorry, I'll show you this one here like so. So I've got a line here and a line which is crossing. What we're looking at here, now a lot of people think of these as, there's two different ways things they use. They use F and Z angles, but I don't like to use them so much. I prefer to think about sliding and then splitting and then opposite direction. So corresponding here, so if I look at this one, like so. So with these ones here, what we're looking at, if I've got an angle there, what I'm doing, in fact I'll colour that in so you can see that it's the angle, make it nice and clear. Instead of thinking about F angles, you're thinking, can I slide that angle here? So if I take this here, like so, and it's parallel, can I slide that angle up? Well, yes, I can. I can slide it straight up there, can't I? That angle slides straight up here. So that means they must be corresponding if you can slide it up. So let's have a look at this one here now. I'll have to change that ever so slightly. So we've just looked at this blue angle sliding up. So let's have a look now at this one. And you'll notice that this one here also slides up as well. But you can think about it as an F like this. I prefer to think about this as a slide, and this is called corresponding angles. So let's have a look at the ones that we've got now on here. So we've got this one here. Get this one down in our books. This is it. This one here is example 1. Example 1. Remember to make sure you're getting in your notes. The only way to learn maths is to do it. So we've got this here coming down like so. We've got two parallel lines. There's our parallel lines. Let's make sure we draw it. We've got this one here. And then this one here is equal to 137. And then we're trying to find this one here. Now, what you've got to think about is, can I slide that angle up? If so, it's corresponding. And you notice that, yes, I can slide that angle up here. See if this fits again, it might do. Not too bad. So it slides up there. So that means that this is corresponding, and it means that they are the same. Let's just check that, show you the one I had before. In fact, we might be able to even make it very similar. So if I move this over here to, what was it, 137. There we go, about right. So 137, and I slide it up, and it's also going to be 137 there, like so. Let's just have a little look at that there. 137, 137, those two angles are the same, and it's because they are corresponding, okay? So it doesn't ask in this question, it doesn't say in this question to give you a reason, but usually, oh no it does, sorry. So the answer is x is equal to 137 degrees because they are corresponding angles. Excuse my spelling, you know that I'm struggling with my dyslexia. So 137 because they are corresponding angles. Absolutely perfect. So if I move further down here, let's go example 2. I mean, I think you should probably be able to do this. It's being able to recognise them that when this gets a little bit trickier. But here we've got two more parallel lines like so. So here's my parallel here. This one here is equal to 52. So what is this one here, and what's the reason? Well, I'll give you a second to think about that. I think you should be able to do that anyway, though. So let's have a little look, see if I can get something to fit. So here's my angle there. I can slide this over, so this angle slides over, in which case they are corresponding angles, and it means that x is also 52 degrees because they are corresponding angles. Brilliant. So corresponding angles, so that means that x is also equal to 52. Brilliant. So that was the first one that we did. So let's have a look at this one here now. So these look a little bit different. Now you'll notice that with this one, if I go back to my picture, which I had before, and I might have to draw a new one here. So let's just draw that first diagram and have a little think about this one. So it goes up and up, parallel lines coming across like so. I've got this one here, which is x, and I've got this one here, which is 132. So let's use what we had before. That angle fits okay. Now notice that I can't here slide this angle. It doesn't slide anymore, okay? Which means that these aren't corresponding angles. However, we can take this angle and alternate the way that it looks. And so I'm going to alternate the angle and turn it round. So basically we've got this line and we're splitting up this line and we're going the opposite directions on the parallel line. That's why it's called an alternate angle. Let's just have a little look at that on our GeoGebra file. So I go into GeoGebra here and I'm going to look at alternate angles. So notice that these ones here, they come up. I'll make this big for you so you can see it. So they come down and up and then across, and they're alternating. They're kind of even pointing the other way, you might say. So that one's 137, but notice they are also the same again. I can swap these so you can change it to the other pair. So there, this one does look a little bit like a Z. A lot of people think of it as a Z angle. But people do get confused because this one here doesn't look too much like a Z, does it? So that one there doesn't look so much like a Z. But it's the way that it's alternating, so you're turning the angle round. And that's where the word alternate kind of comes from. So with this one here, what is x? Well, if we look here, we've got our angle, which is this one. The red angle probably fits better. This angle here, which is this one. Oops, sorry, I need to make that big for you. So we've got this angle here, which is this one, and I'm turning it round to alternate the way that I've got. It's like that Z angle across and then up the other way. So with this one, x is equal to 132 degrees because they are alternate angles. Brilliant. Okay, so these now aren't corresponding, they're alternate angles. So let's have a look at this next one then. That one here was example 3. Remember to make sure. Now, another good idea with this is that when you're try and check, I would always kind of highlight these just to show. So these are the angles here that you've got. Here your angles are this one and then this one, and that's the sliding up. And here the slide's the other way, isn't it? So it's like here sliding down and here sliding down. So sliding, or is it alternating? Okay. Notice how my hand goes like down, up, down. Okay. So let's have a look now at example 4. Example 4. So this time here, my parallel lines are coming down this way, and my line is coming across here. I know that this one here is equal to 48, and I'm trying to find this angle here, which is x. So let's draw on top here. So there's my angle. So can I slide that down? No, I can't. But can I draw the other way? Yes, I can. So it's an alternate angle. Brilliant. So that means that x is equal to 48, again for the reason above, because they are alternate angles. Brilliant. So we've had a look at corresponding where we can slide. We've had a look at alternate where we have to turn it round and change it. We're next going to have a look at these ones here. Now notice that these aren't the same angles. Let me draw again this one up here for you. So this one here we've got, this is example 5. We've got these two lines coming down like this. Again, they're parallel, so parallel, parallel. Worth pointing out, I don't think I've mentioned this yet, but actually this here means that these two lines are parallel, okay? So there we've got our angle. We know that this one here is equal to 134 degrees, and this one here is x, and we're trying to find out what x is. Now notice that if I was to slide this one up now, it's not going to be the same. If I was to alternate, it's not going to be the same either. And that's because these aren't the same angle. This here is worth thinking about and calling. So if I've got this angle here and this angle here, you notice it forms a kind of an enclosed shape. So this here is, sometimes they call it a C, sometimes they call it an N, a C, a U, an N. So if I've got a C like this, or an N shape like this, where these are parallel and these are parallel, or you could have a backward C like this, or you could have a U shape, which is like this. But with these ones, the interior angles here, so these two interior angles are called co-interior angles, okay? And co-interior angles sum to 180. Again, let's have a little look at our GeoGebra file. So here we've got our GeoGebra file. We'll be able to see this one here a little bit more. So look here, we've got an angle here, which is 137.12. And this angle here is equal to 42.18. And you'll notice that these form a 180 degree angle. I'll just make that big for you and change it so you can see it changing. So here we've got an angle here which is 67.96 and an angle here which is 112.31, and they form a 180 degrees, and that's because these are co-interior angles. So so these two here are co-interior, which means that they sum to 180. So I need to do 180 minus 134. So can't do 0 take away 4, so we have to borrow. So 10 take away 4 is 6, 7 take away 3 is 4, and 1 take away 1 is nothing. So I'm just left with 46. Now notice it does say give you a reason for the answer, and this is because these angles are co-interior. Brilliant. Okay, so you're looking for this kind of C shape. It's either a C shape, an N shape, a backward C shape, or a U shape here for all of these. Okay, and it's kind of like they're both it's like inside the parallel lines. So you're looking for two angles which are inside that make 180. Okay, so we'll have a look at one more of these. I think you should be able to do this yourself now. Should be getting used to them. So this one here is example 6. Here we've got two parallel lines going down like so. We know that this one is equal to x and this one is equal to 50. So find out the angle x and state your reason. So this is my angle x, this is the angle I know. Notice that when I draw these two angles, we end up with this kind of shape here, which is like U shape. So it means that they are co-interior. So it means I'm going to have to do 180 minus 50. So 0, 8 take away 5 is 3, 1 take away nothing is 1, which means that x is equal to 130. And this is because these angles are co-interior. Brilliant. So we've looked at the 3 different types of angles, and these are the main ones that come up. So we've got corresponding, which is where you've got that slide. So let's go back to that one here. So where you've got your sliding up and down like this, okay, or this way around. Here you're sliding these up, okay. We've got the alternate angles, which is this one here. We've got alternate direction, and we've got co-interior as well. Now, it's all very well and good when I've actually told you which one to use, but the tricky part of this is being able to spot them yourself. So here I've got a question. So write down the angles, the size of the angle marked A. Now I'm just going to give you a little second to think about that, because I need you to understand how to get that yourself. So this one here was example 7, and am I sliding that angle down? Is it the same but the opposite direction? Am I alternating this, or is it are they both inside those parallel lines? So I think it's quite clear to see if you think about those 3 different questions I asked. In this one here, got down like this, here and here, and if this is 45, and this one here is equal to 135, then what I'm doing is I'm taking this angle here. It's not a very good one. Let's try this one. Taking this angle here. Again, that's not great. Taking that angle there we go. And I'm sliding this down to get X. Sorry, I think Google is trying to help us with our alternate angles there. So just to clarify, here I have got the angle here and it's sliding down. So because I'm sliding down, it's going to be a corresponding angle. So this one here, X is equal to 45, and this is because they are corresponding angles. Brilliant. Now it's important that you understand, am I sliding? Am I in the same direction going the opposite way, or or are they inside the lines? In this case, it was the corresponding angle. So let's just check that. Brilliant. 45. It doesn't actually ask for the reason for that one, but we write it down anyway. So let's have a look at this one. Work out the value of mark X in the diagram below. So here I've got my parallel lines again. This time I'm cutting this way. That was example 6. This is example 7. Remember to make sure you're always getting these down, because the only way to learn maths is to do it. So this one here is equal to 68 degrees. This one here is equal to X. So am I alternating this angle, or am I sliding it down? So if I take an angle which fits, let's see if I can find one. That one there fits. Well, sliding down would be this angle here. Notice that when I slide this, it comes to here. So it's not the sliding. But if I turn this round, does it look the same? Yes, this one here, I've had to turn it and go the other way, which means that it's an alternate angle, okay? So this one here means that X is equal to 68 degrees. Let's just show it again. So it's going to be going that way and then going the other way. So one and then going the other way, which means that it's an alternate angle. You can see this from kind of that Z shape, but I don't like to say this. It's an alternate angle. So alternate angle. Brilliant. So let's have a look at the next one then. So this is where we're going to make it a little bit trickier now. Not too much harder. Well, these kind of questions step up when you've got to do a few different things, okay? When you've got to try and put a few different things together. So it's definitely worth getting this one in your notes. This one here is example 8. So we've got here a quadrilateral, it looks like so. This one here is parallel there. So this one and this one are parallel. I know that this one here is equal to 85. I know that this one here is equal to 120. I know that this is equal to 70. And I'm trying to find X here, like so. Now, the issue I've got is the fact that I've got this 70 here. But how do I get this X? Well, I can't get that X yet. But what I can get is because this here is, these two lines here are parallel, I can see that this here is actually, notice the way I'm going one way and then going the other way. So this angle here and this angle here creates that kind of, that Z shape. So this must be an alternate angle. So it means that this angle here must be equal to 70 degrees. Okay? So this angle here must be equal to 70 degrees. Brilliant. And now the next thing is, how do I work out x? Well, I'm going to work out x because I know that the angles in a quadrilateral sum to 360. So if I do 85 plus 120 plus 70, let's work that out. So 85 plus 120 plus 70 is equal to 275. And then because the angles in a quadrilateral sum to 360, it's going to be 360 minus that 275. 360 minus 275, which is equal to, this angle here is 85 degrees. Okay? And that's because alternate angles mean that this one is 70, and angles in a quadrilateral sum to 360. So, 85, super. Let's go on to another one. Now this one's very similar. In fact, I would like you to have a go at this one yourself, actually. So pause now and have a little go at that one yourself. Okay, let's have a look at this one together then. So this one here is example 9. Very similar to the last one, actually. So here I've got, now they tend to have these kind of triangles in here. They tend to crop up all the time, these type of triangles. So I've got a triangle there like so. I know that this is equal to x, which is what I'm trying to find. I know that this is equal to 50. A lot of people say, well, this must be an isosceles triangle, so this is 50, but that's not the case in this. Okay, we can't just say that it's an alternate angle. Okay, sorry, we can't just say that it's an isosceles triangle. What we do need to spot is the angles that we can work out. So here, you can see that that one there is set 32. But can I find either a corresponding angle, an alternate, or a corresponding angle, an alternate, or a co-interior angle? Well, if I've got this one here like so, I can't slide down. I can flip around and turn around being there like that. This here is an alternate angle, so there. Okay, so this angle here is equal to 32, again because it's an alternate angle. And then we go right back to the first thing we did in the angle facts, and it's angles in a triangle sum to 180. So I do 50 plus 32 first, which is equal to 50 plus 32, which is equal to 82, and then 180 minus the 82 is going to be equal to 98 degrees. Super. So let's just check that. 98 degrees, brilliant. So, example 9. We've got another one here. Now, this one here is looking at isosceles triangles and looking at angles in parallel lines. So, let's draw it out first of all. Again, notice I said that triangles tend to come up in these type of questions. Then this is 4 marks. This has actually come up on the on a past paper question. Example 10 this is now. So we've got our parallel lines there like so. It tends to come up quite a lot when it's parallel lines and isosceles triangles actually. I've seen a few questions that look very similar to this. That one there is x. This is parallel to this one. These two are the same. Now remember that when we did isosceles triangles, we said, if I know these two sides are the same, which one's the same? Well, you pull your fingers down, so it must be these two interior angles are the same. But we'll come back to that in a second. And I know that this one here is 70 degrees. So, there's a few different ways you can do this because you have actually got this line. So the first thing I need to spot is whether it's a corresponding angle or a co-interior angle or an alternate angle. In fact, there's 2 ones you can use here. You could use co-interior angles first and say that these two sum to 180, which makes sense because we've got, these are both inside these parallel lines. But also, we've got this one here, which is an alternate angle. Again, that's Z. So this one here is equal to 70 degrees, okay, because of the alternate angle. We also know that this one here is equal to 130 degrees because these two here, so this angle 70 and this angle 70 are co-interior, okay? But we don't actually need to know that one. So this one here is 70. Now going back to what I said at the start, if this is an isosceles, I can pull this down, okay? And we know that the base angles in isosceles are the same. So this here is 70, but it also means that this one here is equal to 70 degrees. And then we've got this triangle with two angles that I know, which are 70 degrees, which means that I can work out this last one, which is x. So we're bringing in parallel lines and isosceles triangles now. So 70 plus 70 is equal to 140. And then the last little part is 180 minus that 140, 70, 70. So take away that is equal to 40 degrees. Does it say it wants the reasons? No, it doesn't, so that's perfectly fine there. Just in case you do want the reasons, this angle here is 70 because of alternate angles. These two angles are the same because they are isosceles base angles in an isosceles triangle. And this one here is equal to 40 because it's angles in a triangle sum to 180. And then there we're done, 4 marks. Super. So, we've got another tricky one here. We've got 2 more, and then I'm going to give you some questions to have a little go at. So, this one here is tricky, and I've put this one on here because it has come up before. And there's a lot going on. It seems like there's a lot here. So, we've got, it's actually a parallelogram, isn't it? Because these two are parallel lines, and they are the same size. And here, these two are also parallel and the same size. So this one and this one, and this one and this one. We've got this one cutting across here like so. This one coming up here like that. Okay. So this one here is x. This one here is equal to 41 degrees. This one here is equal to 38 degrees. This one here is equal to 120 degrees. Okay. And we're trying to find out this one here, which is x. So, where do I start with this? This one here is question example 11. Remember to make sure you're getting this down in your notes. The only way to learn maths is to do it, okay? So, let's have a little think. Now, the first thing I'm going to spot is if I find out the angles in this triangle here, then I can take away this one and this one from 180 to find x. Super. So, let's think about that then. Well, the first one I can spot is this one here, which is on a straight line, okay? So there's my straight line, and angles on a straight line sum to 180. So I can say that, first of all, 180 take away 41 is equal to this angle here. So 180 take away 41 is equal to 139, which is that one there. Super. So I know that that angle there inside that triangle is 139. Right, there's one angle in that triangle. Let's have a look at another one then. So, the next thing I think about is, how can I get this angle here? So, because these are parallel, you might spot here that this here is the C that we were talking about right at the very beginning, so co-interior angles, which means that this angle here and all of this angle sum to 180, okay? I'm not saying that this one and this one sum to 180, I'm saying this one 120, 38 and this angle here all sum to 180. So if I do 180 minus 120, 180 minus 120, which is equal to 60, I know, I'm going to double line this one, that this double lined angle here, because these two are co-interior, I know this double lined angle is equal to 60 degrees. Okay? But I'm not trying to find that double lined angle, I'm just trying to find this single one in here inside that triangle. So because I know that this one here is 38, and I know that the ones together are equal to 60, I can do 60, so this full angle, take away this little angle here, which is equal to 38. So 60, take away 38, which is equal to 22. So this angle here inside, the red one, is equal to 22, which makes sense because 22 plus 38 is 60, and these here are co-interior, which means that this one here must sum to 180. Brilliant. So we've now just worked out that this one is 22. We know that this one is equal to 139. So the last little stage, let's see if I've got a different colour pen here, is this triangle here. Now look at all these different colours here. Now each of these colours represents a different step that I've had to do. But I've got this triangle here, the last little part, and I know that triangle sums to 180. So I can say that 139 plus 22, so 139 plus 22 is equal to 161 degrees. So in this yellow part, then 180 take away 161, 180 take away 161 is equal to 19. Brilliant. So I know that x is equal to 19 degrees, like so. So that's this one here. So 139, 22 is 161, and then take that away from 180 to get 19, which is that last one there. Super. So let's just check that, 90 degrees. Look at all of those marks there, okay? That's because this is a long question. How many marks was it? 4 marks in total there for that, okay? So, we've got one more question to have a look at here before we go on to anything else. So this is really going to push and stretch you, okay? Now, this here combines solving equations and parallel lines. So this one here is example 12, the last example we're going to look at. So here, we've got some parallel lines, brilliant. We've got a cutting point, and this one here, and this one here. This one is 5x minus 90, and this one here is 2x. Now, I've actually seen these come up quite a lot recently, where they've given you angles in terms of x, and you've got to use the rules that you know to form an equation. So if I look at this one, let's have a little peek there. So this one, I've got a better one than that. Yeah, a little look. Terrible angles here. Maybe I'll fold it so you can see it. So that angle there, that's a little bit better, isn't it? That angle there, this red one, okay, is, I've covered it up, but we've got an angle in there. So notice that I can actually slide that angle down, and it's exactly the same there as it is there, okay? Now, what does that mean? This means that they are corresponding angles, okay? Which means that this here angle is equal to this angle here. So I can say that these are equal. So these angles are equal as they are corresponding. So I can say that 5x minus 90 is equal to 2x. Brilliant, I've formed an equation because I know that that angle is equal to that. And now I've got to solve the equation. Now, do be careful of this because it's an equation with unknowns on both sides. So the first step, if you're not sure on this, have a look at some of the previous videos on solving equations with unknowns on both sides. The first thing I've got to do here is I've got to get rid of the smallest unknown first. In this case, it's 2x. So minus 2x minus 2x. Now if I minus 2x from this side, I'm just left with 3x minus 90. If I minus 2x from this side, I'm getting rid of that 2x, so I'm actually left with nothing. So 3x minus 90 is equal to 0. The next stage is I want x on its own. That's what solving means. So I need to plus 90 and plus 90. If I add 90 to the left-hand side, I'm just left with 3x. If I add 90 to 0 on the right-hand side, I'm left with 90. Last little stage, divide by 3, divide by 3. Divide the left-hand side by 3, I get x is just x. Divide the right-hand side by 3, I get 90 divided by 3, which is 30 degrees. Well, yeah, 30 degrees. So, when I finished that, I found out why x is. Brilliant. So, that was a little bit trickier because we've got an extra added element to that. So, if you do want to go back and have a look at solving equations with unknowns on both sides, do have a look at that one first. So, let's move on now. So, here are some questions. I'll make them big for you so you can see them for you to have a go at. So have a go at these questions. There's actually 2 sheets on this because I couldn't fit them all on one page. So have a go at that, please. I'll pause now. Okay, here's the next set. So pause now and have a go at those next set. 15 questions in total there. Now this tends to be how they come up in the GCSE. Okay. So here are the answers. Mark those in green. So thank you for watching this video on angles in parallels line. Make sure you're having a go at these questions, because remember, the only way to learn maths is to do it, and have a lovely day.